Okay, let me talk about chemical equations. You'll need to read pages 225 to 229 in the textbook and answer 1, 2, and 3, which is on page 229. So far I've had 2 classes do this. Question number 2 is not a multiple choice question. They want you to go back through and put the coefficients in to make them balanced. All right? So if you put B, that's the wrong answer. Okay? It has like three different chemical equations they want you to do. So make sure that you answer all 3 of those to get the point for that. So the objective here is to understand what a chemical equation can tell you. A chemical equation uses symbols to represent a chemical reaction and shows the relationship between the reactants, which would be this side of the equation, and the products. Okay? These 2 things react to form these 2 products, in other words. All right? So the way we're going to do it is the arrow is going to point to the products. Now in chemistry it's a little bit more complicated than that, okay, but that's the way that we're going to show it. I think it'll be easy for you guys. So this arrow sign means yields, okay, or produces. So the atoms you start with on the left, you should end with on the right. So if you notice, there's a carbon here, a carbon here. There's 4 hydrogens here. There's 2 times 2, 4 hydrogens here. There's 4 oxygens here. There's 2 oxygens plus another 2 oxygens here. Okay, because matter has to be conserved. All right, mass is conserved. So we add coefficients that's these numbers right here out to the side to make them equal. We can't change the chemical formula because water is H2O always, right? So if we make it H2O2, it's not water anymore, it's hydrogen peroxide. So the only thing that you can change once you get the correct chemical formula is to add what are called coefficients to the front of it. So if we read through this, CH4, we would call it carbon tetrahydride. It's actually methane because it's an organic compound, which doesn't matter. We didn't get to naming organic compounds yet. But 1 methane reacts with 2 oxygens, 2 oxygen molecules, to give us carbon dioxide and 2 waters. Is really what's happening here, okay, at the molecular level. If you have methane in 1 oxygen atom or 1 oxygen molecule, the reaction can't take place because there's not enough oxygen to produce what we need over here. Okay, so this is really what happens at the molecular level. Does that make sense? At the atomic level. So this side, the number of atoms on this side has to be equal to the number of atoms on this side. So we're just really introducing this today. We'll spend a lot of time balancing equations and putting coefficients on it and show you how to do that. So after you get done with the quiz, there's 2 things you need to do with the rest of the time. You need to read through this and answer 1, 2, and 3. Make sure you submit it on Canvas. And then on that worksheet, this side here is pretty self-explanatory. The other side, there's a couple of things I want to talk about. They give you some, you can get it up here. They give you a couple of chemical reactions here. Okay, here's one, here's another one. And then they've got some stuff in parentheses. All that the parentheses stuff means is the state that the substance is in. Okay, so if it says Zn and then Cr in parentheses, the Cr means crystalline solid is all that it means. Okay, or solid. If there's an L, that means liquid. If there's a G, like down here, that means gas. And I think that's all they ask about. We're not going to write equations like that. We're not going to put the states in, but you may see it at some point in time, so we'll go ahead and ask you about it. But that's what they're saying here. They're saying zinc as a solid reacts with sulfur as a solid to give you zinc sulfide, which is a solid. Hydrogen gas plus oxygen gas gives you water, which is a liquid. That's all that it means, okay? We'll actually get rid of the parentheses stuff once we start doing it. But the rest of that stuff should be fairly simple.